Warm greetings and welcome, dear students and friends. Now I am going to take a lecture video on Rankine's theory of column. For the given data, what will be the safe load using Rankine's theory of column, and what will be the Rankine's critical load for the column. A column with both ends hinged, which is made up of aluminum material, is of actual length 2 meter, subjected to an axial load P. So that is an unknown quantity that you have to find, and using a factor of safety of 2, and you take the sigma C value, that is compressive strength of the aluminum material at the failure is 550 megapascal, and the Rankine's constant alpha is equal to 1 by 7500. The column is made up of aluminum tube, so which is of 32 mm outer diameter and of thickness 4 mm. So what will be the Rankine's crippling load and safe load on the given short column? Now we are going to give the solution for this problem. You know that the area of the steel tube is pi by 4 into capital D square minus small d square. So that is equal to pi by 4 into 32 square minus the internal diameter is 24 mm. So 24 square. If you are working out, the area of the column is coming out as 351.85 millimeter square. And in the case of the lambda value, that is slenderness ratio for the short column, is the ratio of effective length divided by the minimum radius of gyration. So the effective length is here of hinged both ends actual length, so it is of 2 meter, that is 2000 millimeter, and the minimum radius of gyration or minimum is equal to k, that is equal to square root of I by a. The moment of inertia, least moment of inertia, being the hollow circular section, Ixs is equal to Iyy, so that is equal to pi by 64 into 32 to the power 4 minus 24 to the power 4. If you are working out the value of square root of r by minimum is equal to 200. So lambda value is equal to 2000 divided by r minimum is 20. If you are working out, r minimum is 20. So you are getting 200. So that is the slenderness ratio lambda. Then if you are finding the critical load for this column using Rankine's theory, that is equal to sigma C into the area divided by 1 plus Rankine's constant A into the lambda square, that is the slenderness ratio of this column square. A substitute value of sigma C is 550 Newton per square millimeter into area is 351.85 square millimeter divided by 1 plus A. The Rankine's constant is, you know that it is 200 into 200 square into the alpha Rankine constant is 1 by 7500. So if you are simplifying all these values, numerator and denominator, you are getting of around the Rankine's critical load of P suffix R, that is equal to 30.55 into 10 power 3 Newton. So it is nothing but 30.55 kilonewton. Then the safe load is Rankine's critical load P suffix R divided by the factor of safety. So it is 30.55 into 10 power 3 divided by Here factor set is given as 2, that is equal to, we are getting the safe load on this short column is 15.25 into 10 power 3 Newton. So that is equal to 15.25 kilonewton. So this Rankine formula is applicable for short column as well as long column. What will be the type of column you can apply, because the factor is given in terms of including both short and long column. But in the case of Euler's theory of long column, you can apply only for the long column. You cannot apply for the short column. That is the biggest advantage of the Rankine's theory of column. Either you can use it for short column as well as long column. So this is the way you can find the crippling load and safe load for any types of column, either fixed column, hinged column, cantilever column, or one end is fixed and other end is hinged. Thank you very much for patient listening. வாழ்க வையகம், வாழ்க வளமுடன்.